All right, everyone back. It's hard to know.
Yeah, it's virtual. We're
getting some thumbs up.
Sweet. So excited. We're about to kick off the meat of this thing. It's going to be real fun.
Cool. All right. So first things first. This is application overview and risk assessment.
Cool. Do you want me to talk to this? I can speak to this a little bit.
Yeah.
Sweet. Yeah. So, oh, wait, hold on. Click start to, that was weird. Anyways, cool. So these are the three primary parts of, an application overview and risk assessment. So as we're beginning to sort of, what are these? Sorry. Trying to find somehow. Oh, okay. I see what happened, Seth. Okay. You gave me control of your screen. I was a little confused there. All right. I was like, where did my chat stuff go? Where did all, yeah. Okay.
Oh,
all
sorry.
right. This makes sense. No. It's all good. I was just like, that's why I was thrown off. But it's not your fault. It's mine. Anyways, so back to application overview and risk assessment. So the three main components are behavior profile. We liken this to like an FBI behavior profiler, right? We need to know some things about this application, again, to give context around everything else that we do. So this is incredibly important. This whole application overview and risk assessment, along with the next section that we're going to cover after you do an exercise here, and we'll reiterate this over and over again, this is absolutely not optional. So in every review type that you do, doesn't matter which one, this is not optional. This has to be done. These three things. So behavior profiling, understanding the technology stack, and the app archaeology. Let's see here if I can. There we go. So behavior profiling. These are just some very basic questions. Realistically, you're going to build more and more of these questions as time goes on, but this is sort of like a good start, right? What does it do? What is the business purpose? Why does that matter? For a lot of reasons. One that really I think is important is understanding, what is the point of this application? What would be outside the norm of expected behavior? So if I am, say, a site that sells items and I have some sort of couponing system, perhaps I don't really want that coupon system to, allow multiple coupons per, customer per checkout, right? But if I'm going into the source code and I'm doing a review which encompasses many, many different things and feels a little bit complicated, and maybe you're just learning an entire application up front, those little nuanced things, you may not catch logic flaws around, or business logic flaws around where sort of maybe authorization that prevents some behavior like that occurs. Like you may not even know to look for that, is what I'm trying to say. You may just say, okay, well, the couponing system, doesn't allow the same coupon to be used more than once, but maybe it's not as, like, hey, you're actually not supposed to use more than one coupon, period, no matter if they're, unique or not on a checkout flow. This is just one example. There's a lot of, as we build our methodology together, which we'll be doing, you're going to see like there's things we need to know, and we'll go through documentation, which is part of the app archaeology section, to determine like these types of things. What is this application? What are the boundaries we shouldn't be crossing? Who does it do it for? Is it internal, external? That's not necessarily just about risk. It's like, oh, well, it's less risky because it's internal, or it's external. It's actually like you'll see in one specific example of an exercise we do where, if there is if there are both internal, like if you're, I think the term, dog fooding is one that most people have heard, where, like at GitHub, we use GitHub to do our job of building GitHub, right? So we have external customers using the same systems that maybe have elevated access for us, right? Because we're internal and we use the same product to make it. So, it's like these things are important because, well, again, you'll see examples of this, but it's just, again, very important for context. So if there's, for instance, say email enumeration or something like that, or employee ID enumeration, and you've got your company using the same application that you're providing as a business thing to external customers. Well, guess what? Now you're at risk too. It might elevate the actual impact of a vulnerability. So there's just a lot of things you need to know about, like internal and external, or that, or just your customer base in general. What kind of information will it hold? When we talk about sensitivity of data, and like especially Seth's favorite, one of Seth's favorite topics, and I always give him some grief about it because it's so boring, but it's such an important thing though, is auditing, right? So, and this is important because when we talk about different auditing like logging flaws and nuances that we've seen and weird things that happen, it's important to know what kind of data is going to be flowing end to end through various systems. Sometimes it's a service-oriented architecture. You're going to have multiple applications talking to each other. And really, honestly, knowing what type of information is flowing is going to change quite a bit about how you look at certain things, like, for instance, auditing. I don't know if there's anything you wanted to add so far before I hit these last two bullet points, Seth.
No, I mean, these are all just, these are questions that we typically, as a consulting firm, right, we'll ask this to scope out an application, right, to understand how much work it's going to take for us to actually review the source code, right? And it's all indicators of what the risk profile is. That's realistically what it boils down to. So, sorry, go ahead, Ken.
Yeah, no. That's spot on. Different types of roles, like what types of roles are inside the application is pretty important to know. Whether you've got author, editor, whatever type of application you use, whatever roles are in there. Like, that's what I mean is not just admin and user. It's like, what are the various expectations around maybe role-based access control and things like that. But you won't know. All of this feeds into each other. So each section feeds into the next, and you'll experience why that's important when we talk about different types of roles. But the last one is arguably one of the most important questions to ask. And again, Seth touched on this earlier, but I'll reiterate, you should always ask the customer, the client, the developer, whoever you're doing this service for, you should ask them what concerns them the most. You'd be surprised. I find that more often than not, those concerns are the actual biggest impact things that I end up walking away with an assessment anyways. So I could sit there and spend my cycles for, forever. And that's, maybe even focus on the wrong things. But I think it's important that you concentrate on first, what are these things that they're concerned about? And that'll just make sure you have your bases covered. And you're really, like, again, talking to like what lines of code that you should actually be assessing in your limited amount of code that you can assess. Obviously, you should be prioritizing the concerns of folks you're performing a service for. And there we go. Technology stack. This is a very condensed slide, because as we go through it, you'll see why this is why this can be like many, many, many slides. But condensing it all down, framework and language are just sort of the jumping off point. Now, versioning is very important with frameworks and languages. You'd be surprised, or maybe you wouldn't be. The version, even minor version changes can have various, like Django's a good example of this. There are certain things that you don't have to be concerned about in newer versions of Django that you definitely would have to be concerned about in earlier versions. This is true for most web frameworks, especially major versions. There's always like different security documentation, things get updated, things change. So you may have, like a legacy version you're reviewing, and it definitely is vulnerable to XYZ, whereas something else isn't. And so knowing just like, The framework and language versions is important, but it's not just that. When we go through and we break down different components within what comprises an application, you're going to see that when we talk about where to research, like say, for instance, routing related vulnerabilities or data processing related vulnerabilities or authorization decorators or anything like that, there's going to be specific ways those things look in these frameworks and well, in the frameworks. And the reason we talk about the language is the languages themselves have certain, maybe it's OS command language things, maybe it's a certain type of, so something else threaded, maybe there's threading concerns. Just there might be nuances in the language, which again, you'll see in this course, those nuances. And so you need to know that part of the technology stack. And when we talk about third-party components, yeah, this is always a really interesting one. I think dependency confusion attacks and dependency chain and supply chain attacks in general, I should say, have been on the rise. I can personally speak to that, having worked at GitHub. Obviously, we acquired NPM. We have registry, package registry things. We have the action service, and none of this is because I'm trying to promote where I work. This is all important because it's all really, honestly, rebuilding package. Like there's an actions, almost like package manager ecosystem, and obviously there's an NPM ecosystem for package management. And so I've really had to deal with a lot recently around supply chain attacks. And so this is becoming incredibly important. And then just like weird things, we've seen weird things where like someone wants to throw in a marketing widget, but it maybe does a refer off to another site. And in the refer, it's got maybe in the URL that you were looking at that widget, there was like a sensitive value in the URL, like a token or some PII or just something that you don't want another third-party site you don't own to see, and it just like gets included in refers. It's just, you need to know like what are the different weird things that people are including. Obviously, if you're including third-party JavaScript that you didn't write, it might be out of date, might have vulnerabilities that were discovered. And then just like also being reliant upon other applications. I briefly mentioned service-oriented architecture. Yeah, so if you're reliant upon receiving data in a certain way from another application, or if you're providing some service-to-service communication where like maybe you have some, I don't know, like HMAC verification to secure that communication or whatever it might be, very important to know. And then lastly is your data store, right? And data store could be as simple as like files. It could be relational databases. It could be in-memory databases, whatever it is. This is incredibly important. It's going to factor into, like what ORM are you using, or like, library to interface with one of these storage mechanisms. Super important to note because we're going to show you some versions here of Active Record that have like serious flaws depending on which version you go with. Just as an example, MongoDB NoSQL injection is very different from, say, MySQL injection. So it's important to know this technology stack. Just checking. I heard some. Okay, yeah. All right, cool. You want to talk a little bit about this, Seth?
Sure.
Or do you want, like I did go a little fast. Is there anything on this slide you wanted to cover?
The only thing on the third-party components, like Ken was talking about the supply chain attacks that have popped up. There's utilities nowadays that help us with a lot of that, whether that's Sneak or dependency check, on identifying what those components are. The one thing we don't want to do is be blind here as far as what it is that's being pulled into the application. So looking through those packages or analyzing those packages becomes fairly important. But that's all I wanted to mention there on those third-party components, was that there are those tools that we can use. Once we have a good idea of kind of what the application looks like, what the dependencies are, we're going to start jumping into the archaeology of that application, right? We're going to look at the documentation, right? README is usually a great place to start here, right? If you haven't done that already, it's going to give you indicators of what the application is or what the source code is intended for. If the developers are good at keeping up their documentation, this is extremely helpful. Even, it goes back to that initial slide where it's like, oh, if you can build the application, because it's going to show you what those third-party libraries are, what the different documentation is that's out there, and what the dependencies are, why the application runs, how it runs locally in a development environment. And then we'll start to point you at, oh, it looks like I need MySQL or Postgres or Mongo set up for the application to interact with, even if it's not called out in the documentation itself. And then at this point, we're going to look at what else it interacts with, right? We can do some spelunking with Git, right? Git log, searching through there for to-dos or security events, just to give us an idea of what has recently been pushed into the application. And this is only if you have the Git history, but most of the time they will zip that up and send it to you if they don't just add you to their repository as it is. And then unit tests. Unit tests are one of my favorite places to look to get to know an application, because it points us in the direction of what the developers really care about when it comes to the application. Right? It shows us the integration tests. It shows us those functions that are important that have to run every single time, because if they don't, the application breaks and it doesn't work as intended. And so you can also, you can use this to form a request in a dynamic assessment if it exists, but it also shows us the super interesting endpoints. As we're getting into the mapping, it kind of points us that direction, right? If we could run the unit test, but at the very least, let's look it up, let's open it up and see what's available in there. But I mean, there's nothing more disheartening to me as a code reviewer, especially looking at a full application, is to open up that test folder and to see just a generic test where it tests to see whether 1 is equal to 1, right? Where the developers haven't actually put in the time to build those tests. It means that it's going to take a lot longer, but it also usually means that there's more to find and there's more that I can actually jump into there.
I want to briefly, real quick, share my screen there, Seth. I want to real quickly show some spelunking on GitHub. Git allows you to do this in general, which I can certainly show here. But yeah, let me share my screen.
Okay, I'm stopping mine. Go ahead.
Sweet. All right, you should be able to see my screen. So I'll show the command line. The command line version is pretty, I can always go through, and I don't enjoy the command line version as much, because there's git log, that's great, git log -a, all of that. -a gives you a little bit more of details in terms of what's actually changed. And so you get your commit number, you get some information about when it happened, what all had been merged. So pull request merges, which is really cool, useful, etc. Obviously, there's git blame, and I could choose pretty much anything here. We'll just go with package.json, and I can see the commits, the last commits that happened on each line of the code, and the dates and what changed and all that. That's great. I don't like that as much as obviously going through the UI. I'm not, again, GitLab, what's the other one? Bitbucket. Whatever you want to use, that's fine. I'm just showing you one example of what I find to be useful. So sometimes I'll be like, hey, maybe this is something I want to see, hey, when did that change and why did that change? So I'll typically go, this allows me to go to the pull request that it was introduced. And also this allows you to go back prior. So if I click on this, I can go back prior and see, okay, well, prior to that 2 years ago change, there was something 6 years ago done. And again, you can always click on, go to that PR pull request, and you can actually go to the number here and pull up. Now, there's not a lot of conversation here, but where I work, there's a lot of conversation on every PR. There's a lot of comments under the actual files changed. So that's really, for me, helpful when we talk about context. Like, why did something get introduced? Did anyone, sometimes it's like, okay, I have literally found a pull request when I went back where I made a comment and was like, hey, you should consider doing this. And then like it wasn't done. And it's like, oh, okay, well, that's a whole other thing, different problem, but whatever. Like at least it showed me some background history and context. So again, I encourage people to always use whether you're using Bitbucket, GitLab, whatever, use the blame functionality, learn it well, and it'll give you, like I said, some context into changes that have been made. So we can go back to sharing your screen there, Seth.
Okay.
If I can figure out how to do Zoom correctly. Let's see here. Or you may be the Zoom. Here we go. Stop share. I see it. Perfect. It's all you.
All right. So that's app archaeology, right? At least to get us some pointers around what's going on with the application. And when we're dumping into this in the initial section, like it's probably not like, hey, let's not spend 2 days just digging into this app archaeology, but enough time that we start to understand how things are put together and why they're put together in the way that they are. So if we're looking at Behemoth, right? This is one of the tests. This is an example of a test, right? They're building out and they're testing their password service, their password validation, to see whether or not something is a strong password or a weak password. I mean, this is what you want to see as a security reviewer, as far as, hey, what is it? What are the restrictions that are there? There's some authentication checks that'll go into this as well, but they've already put some thought into it. So we know, hey, there's a password meter service, there's a session service. Both of those are things that I'm going to be looking into in the future. I can probably make a note of it as I'm building out my app archaeology, but at the very least, it points me in the right direction.
Yeah, and there's some reasons that unit testing can be incredibly helpful to read inside of a source code. So when you read some source code, some unit tests from source code, a couple things that are interesting are like, hey, here's how my request is supposed to be formed. Because sometimes, like you'll have a live running version of the application and you'll have the source code. So you can actually validate your assumptions. That's always really nice. Whether you have it running locally or whether you have the app running at some staging or production or whatever, that's always a nice thing. And so when you get into the situations, but maybe you're sending to an API and your request needs to look a certain way. These unit tests help you learn how to form those. But also the other thing about unit tests is it's kind of a warning, right? If the unit tests are light, or if you have an application that relies really heavily on like role-based access control or some sort of set of authorization functions to prevent people from being able to do things they shouldn't be able to do, but there are not a lot of unit tests, that's a red flag. I mean, this is going, and you're starting to put yourselves in the shoes of the team that built an application. And it's starting to give you an idea of like risk, right? Not just risk, but behavior, expectations, how people who wrote this application work, really. So for me, that's helpful because like when I don't see authorization, both negative and positive authorization test cases included, meaning negative, meaning like you shouldn't be able to do this thing, then I get a good sense that like, hey, I may actually find some pretty serious flaws in authorization here. Just like a kind of a pro tip there.
Yep. Good. Okay, so that brings us actually to our first exercise. Woohoo! You can jump in, and this is going to start with Behemoth. We've talked about it a little bit, but we want you to do the initial analysis, right? So the application overview and risk assessment of Behemoth, just based on what we know and what we've pulled down from GitHub so far. These are the 4 things that we want you to look at. First of all, the tech stack, with the business purpose behind it, application risk, and then anything else, right? That you find interesting within the the 15 minutes that we have for this exercise. Behemoth was, let's see, do you want to drop that in there one more time? Oh, yeah. And for Napoleon, right, you want to start from that example template, right? We've got those questions all listed out. You don't have to retype any of this. You can just pull down that markdown file that can referenced in chat and start from there. If you've already copied, or if you've cloned that repository, the handouts repository, you can just copy that template directly, but I'd make multiple copies of it because we are going to do this against multiple applications. The idea is to exercise this in practice over and over. So make a template for Behemoth and let's get started on it. Ken, any other instructions there?
Yeah, let me actually just real quick again. Sorry, I have to share my screen again here. I just want to show something real quick. So, right. All right. So here, this is the link I gave you. You can go to Raw. So again, click the Raw button and just straight up copy and paste into Atom and create your notes. Now, the only thing for this exercise that are relevant, just omit basically all the finding stuff, right? You want to go straight for we assessed commit number. And again, you can find that just by going to git log and you can find your commit number there, right? So you're going to find your commit number, place that in. I'm only showing you this the first time because, you know, I mean, it's the first time you're going through it. And then these are, you know, in the slides, it tells, we're going to put the slides back up, but basically behavior, tech stack are the main things here. Give me one sec here as I go back, validate that assumption. Yep. Yeah. So basically you should start to fill out the behavior, the tech stack portion. And if you would like, I think it's helpful to start thinking about just some basic risks. So up in the slides, we'll put them up, but basically it's tech stack, business purpose, application risk, and just anything else that you want to throw in there as well. So now make sure you, like I said, you can pretty much dump everything else that's not that. So it should look like that. We assess the commit and these three major sections. And then like Seth said, we'll take about 15 minutes to go through that. And then we'll do a post-mortem review of, of this exercise. So there you go. Handing it back over to you.
Okay, there it is. So go ahead and jump into that. Feel free to chat or, you know, ping us via voice if you have a question as you step through that for Behemoth. Everyone has the repository, correct? Or if, yeah, let us know if you don't know where to go with that.
Sweet. Pencils down. No, just Seth's joining back up here in a second. As if people had pencils. Okay. Sweet. Getting some feedback here on something. Cool. Awesome. Well, as we go through this, I think it's important to explain that at first, for some people, this might seem like we're going fast. For others, it might feel not the case. We are absolutely going to make sure that everybody's on the same page as we go through this. So right now it's a little nebulous, I'm sure. But yeah, we're going to dig in here shortly and run through it. I'm just waiting for Seth to finish up a side conversation before we proceed forward here and cover the output of this first exercise. And the reason this first exercise, it's going to be important that we cover this pretty in depth, like in terms of opening up different aspects of the application. Just know that we've done this course a bunch. It'll all fall into place. If you're at all worried, don't be. It's all going to fall in there. But I'm kind of just waiting here a second.
Yep. Sorry. Okay. So as far as this one goes, I wanted somebody else to speak to these different things, right? So I'm trying to decide if we should have somebody jump in and give their rundown on this, or should we just have them post the tech stack in? How do you want to handle that?
Yeah, I mean, I think for now, we'll sort of ask questions and have people just pipe up. Either you can unmute yourself and pipe up, or you can just put it in chat. But I think we should run through, like business purpose, the tech stack, documentation, see what people have found. Usually, just so everyone knows, usually when we're in the class, we just kind of shout out everybody's feels free to just kind of like shout out and, like what they found and what they learned. But here in a virtual setting, it's going to be a little bit different where you have to sort of unmute or you have to post into chat, but we'll start digging in here now. So yeah, first question would be business purpose. What does the application do? What does Behemoth stand for? Yes, it's a free open source accounting and hospital information management system tailored for the healthcare system in Africa. And tech stack. Can anybody tell me the basic language / framework that this application uses? Angular, Node.js. Yeah, so there is AngularJS for the client side JavaScript. There is the server side is the Node.js. And in terms of the web server bit there, it's got Express. I see some MySQL thrown in there. That's great. Yep, MySQL. Awesome. Yeah. Redis for session management. Very, very good call out. Very good call out. So just off the top of folks' heads, what are the risks that you might just sort of immediately be concerned with knowing some of that information? So I see outdated framework versions, exposure of potential medical data or finance data, large amount of dependencies. All those are correct for sure. Cool. Yeah, client-side JavaScript vulns, absolutely something that you would be concerned about, especially with something like a large client-side JavaScript framework, like say Angular or something like that. Let's see what else. Okay, cool. So can we go to the next slide there, Seth?
Yep.
Cool. Awesome. So yeah, it's what you all said, all of these things. I think what's interesting is to actually walk through some of these bits. So I'm going to share my screen and walk you through this first bit of the how we did this. So this goes to sort of me saying, hey, we are going to walk through all this. This is sort of you're giving your first best attempt, and then we're going to walk you through sort of what we see when we do this. And then hopefully this will begin to give you some, well, not hopefully, it'll begin to give you some level of comfortability. So I'm going to share my screen now and start in here. So first things first, whenever I come up to an application, I want to check out the README. No surprise. The README file is, very common in most applications. There is like a README style file, and it may not be titled README, but there is usually some introduction to the application in some way. So I like to read the documentation. I like to understand exactly what I'm looking at. I want to know what the purpose of this application is, who's building it, how to contribute, what is their like release cycle. Some of that's in there. And obviously like the installation guide, it's a good place to also learn a little bit about the tech stack. So if we go and open up that installation guide, immediately you see some things that are helpful to us. Like we know the MySQL version, which we can dig into the code to actually verify that's accurate. Obviously sometimes documentation and the code are not up to snuff. But just to reiterate how we got here to this page was just by opening up the README and doing a little bit of digging. There's some interesting things here. Like if it's MySQL 8, I think it's MySQL 8, where they captured the issue with auto incrementing IDs and primary keys, where say you delete a record, or your migration of new data into a database doesn't go quite right, and say like user ID 3 is skipped, or like isn't included in the row, instead of auto incrementing to the next level, it'll just be like, oh, user ID 3 is now this other person. And so there's like various nuances to versioning, like I had mentioned earlier, that have like pretty serious outcomes depending on the version that you are looking at. Now, I'm not suggesting that everybody just knows these types of things off their hand. What I am saying, or off the top of their memory or something like that, but I am suggesting that you go in and you actually look at the versions of these different things and look for like common security issues with that. But at this stage, that's not what we're doing, right? At this stage, we are just purely information gathering. So now I can start to fill in the blank on like, hey, these are sort of my, this is sort of my basic tech stack here. And I would start filling in some of that information. And also I would look at, there's a developer wiki. So there's an entire wiki on explaining like how to get this up and running. That's incredibly useful. Sorry, I see some questions here. Okay, no, all right, we're good. So going back to it, yeah, you can find out a little bit about the tech stack. You obviously can find out a bit about the business purpose. There's documentation here that helps us understand a little bit more about the application. Now, going into a little bit further with this, and like we've called out here, obviously patient data, employee payroll information data, or payroll information, that's all super important to list out as a potential risk. There's a lot of resources here that we could really dig into to understand a lot about this application. We can look at their unit tests, and we can find out how this application builds its unit tests. We can go look in the actual application at its tests and start to understand its expectations. It's that there's a wealth of information that all of this is able to give us, right? So it really gives us an idea without ever having, honestly, if I had nothing else but this source code and I couldn't even click on this and go to the website, I would still get enough information about this application and like the purpose behind it and how it's built and how it's what it's comprised of to be able to start doing my job essentially, and start doing my research. But this is the first step. Before we go any farther, this has to be done. And I'm going to move on to the next slide, or sorry, the next. This is a little weird because we are virtual, so it's a little hard to show that. I'm going to put this, let me move this version down here so you can see my next sort of output here. Sorry, it looks really weird. I'm trying to figure this out. Present to view. All right, so we're going to look in a few just basic places inside the application that pretty much immediately give you a lot of information, honestly, a lot of information. So let's start with config routes. So this is just an express. All right. So we're in server config express. Now, why we chose that is, again, I'm not suggesting right off the top of your head, you're going to know immediately where to go inside of an application. But when you do your homework on a Node application and how it's basically made, there's always sort of this like first file that kicks off like getting the app up and running. And in this case, it's the express.js. And when we go in there, we immediately see some pretty interesting stuff, right? We see, to the point of the individual who mentioned the Redis store being where sessions are stored, we immediately see some information there around that. We see Helmet is used. Helmet is, so like what part of this methodology is understanding, like I said, that the technology stack and knowing the security-centric libraries, we talked about it in third-party libraries, knowing the security-centric libraries are incredibly important. So, and I'll get into that in a second here when we delve into the package.json. But just off the top of my head, I mean, I know that Helmet is a security impacting library, and I need to look at what options were configured there for Helmet. Just by looking at this, I can see, okay, well, we have public routes. These are presumably routes that you don't require authorization to hit, right? So I can immediately start looking at like, how is that used? And I can see like, oh, there's this logic right here immediately around sessions, and like, if there is no session and the request path matches the public routes, then we are going to reject access because there is no session. We're going to, this is essentially a log statement here. We're auditing. We throw some error, and otherwise we just move on, right? We're allowed to proceed through. None of this stuff is anything at this point I'm suggesting anyone writes down. This is more just an exploratory phase, right? We're going in and just trying to see some initial things. And part of this is giving you the understanding that in a short period of time, you can understand a lot about an application. Even here, when I see something like this, I cannot tell you how many times I see secret reuse, where especially for some reason, I don't know why it's so prevalent in Node apps, but I see this where the same secret gets reused elsewhere in an application. Like I've seen session secrets reused for HMAC verification, reused for like a database password or something like that, or a webhook validator secret or something weird like that, where, like I said, there's multiple times this gets used. But all of this right now is more for you just to understand basically how an application looks, how it works. Okay, we have an uploads directory. These are all things that you might choose to make notes on. You may not. It is really up to you. But mentally, definitely you're taking notes, right? If you're not writing it down, you should at least be thinking about this stuff. So that's the first one. We're kind of opening up this file here.
I did want to, sorry. Yeah, Ken, I wanted to bring something up too, right? As you're diving into this, remember one of the principles that we've got here is to stay on task. It's very easy once we open up a code base, especially if you're familiar with it, to start looking for vulnerabilities just right off the bat. And we're going to talk about this quite often. because we could start jumping down oh, I'm going to trace through and look for SQL injection, right? Because it's kind of an easy thing to identify and start searching for select statements and bypass the required get to know the code base step, which is going to give us more vulnerabilities in the long run. And if you take anything away from this course, it's to do things in the right order, right? So the more that we spend kind of upfront getting to know the code base is going to pay off down the line when we actually get into the review items, when we're looking for injection, when we're looking for the other vulnerabilities. So don't go down that rabbit hole. Both Ken and I have gone down that rabbit hole and wasted time and burned cycles when we should not have. So stay within the lane of what you're trying to accomplish. Get to know the application now. We'll get to the rest of that in an appropriate time or at an appropriate time.
Yeah, the expectation is that at a minimum, you walk away with this at this stage, right? Not a whole lot, not a whole lot at this stage. But however, the point here is to show you that even just by digging into a few key centric places that we just kind of cherry picked out of the app, we were able to find out a lot about the application, right? Like there's this auth. So there's this server controllers auth function. And immediately it shows us like some interesting information. It shows us the login route. It shows us how the logic behind that works. We've got some pretty interesting SQL injection, string put in here. So there's SQL content in here. Immediately looking through it, it's like, okay, well, this is an interesting security impacting file. Like if I'm making notes and I happen to stumble across this as I'm just browsing through the source code, and looking at I can just really just look through this and spend a ton of time, or I can just go for things that seem like they're maybe interesting. But at this point, all I'm doing is just surfing around, just trying to understand the application a little bit better. This is totally just to show you that in a short period of time, you actually can find out quite a bit about an application. So sorry. Here. Again, here's another, we know now there's an administrative aspect to this application. There's a user's API endpoint. Just helpful information to kind of understand how this application's comprised. But again, our primary goal is so much in here, so much in there, right? Primary goal, though, really just understand these bits: business purpose, tech stack, documentation. And however more you want to kind of just browse and look around is up to you at this stage. But that's really all it comes down to. So I'll hand it back over to you, Seth. So again, nothing super fancy, nothing crazy, just pretty basic at this point.
So does that feel like something everybody can do? We haven't blown any minds quite yet, right? Quite yet, right? We'll get there, but quite yet. All right. So most important thing is to understand the application. We can't find vulnerabilities in something we're not familiar with. And that goes for any sort of security assessment that we're performing, right? If that's a dynamic assessment, if we don't understand how the application accepts input, we're not going to be able to see if there is SQL injection, right? And the same thing goes for the code, right? If we understand the application, how it's put together, the roles that exist, the archaeology, we're going to have a lot. It's going to be easier to identify the flaws that exist in that code base. If we just jump it straight into the vulnerabilities and we get too quick to reviewing like the OWASP top 10 items or something else, we may miss large portions of the application or business logic flaws that could be the real concern of the client or of the developers. So one of the first things so one of the first things that we're going to do during this information gathering phase is identify what we call authorization functions. And Ken, why do we call it that? Why do we call them authorization functions? How does this differ from normal authorization?
Yeah, so at this stage, we're interested more in understanding So there's two pieces listed here. One is the application map, which is just a source to sink, right? That's literally all that is. We want to know like where are the entry points within an application and where do they flow off to? And then which of those do we need to prioritize? Because we're going to get into that, but again, like if you have a limited amount of time, you may only choose a subset of everything you've mapped out. You need to map it out though first to get a full list, a comprehensive list. And then from there, you can decide what to not review and what to review. Maybe some things are just repetitive and unnecessary or not security impacting. But either way, you need to map it out. The identifying of authorization functions. So this is not the same as later we have an entire section dedicated to authorization checklist, right? We have a review checklist that goes through all the different things that can go wrong in authorization, but that's not what we're doing at this stage. What we're trying to do at this stage is literally just list out the names of different authorization functions, understand how in that application framework or web server, how they're applied. So we know what to look for, where we should be seeing things applied. So like if we have a pretty basic authorization filter that maybe just checks if you're logged in, well, if it's not a public facing page, it probably should have that. So we'll talk a little bit about how to find where in those cases when it's not applied. But primarily, we just need to know what the authorization functions are named, what they look like, how they're going to be applied. Later, when we dig into authorization specific vulnerabilities, that's where we use that information that we've set as our foundation. Most of this is just setting a foundation for your later work. So going forward.
Yeah. And I mean, creating this application map it's all about us getting to know the application and understanding the ins and outs. So we look at a lot of web applications in this course because it's easy to identify what those maps are. But this same sort of map is also applicable for mobile applications, for libraries. If you're doing a code review on a library, it's all just a matter of where does this application accept input? And what does that look like, right? Is it everything's trusted as it comes in? Is it, hey, is there an authorization function there to limit what someone can access or not? And all of that's going to come into play for risks later on. And like Ken said, we're going to get into the authorization vulnerabilities that exist and broken access control, all that kind of stuff. But at this point, we're just trying to figure out how the application does things. If we go back to the Behemoth example, you saw interceptors, right? If you noted in that one app.js file, that's usually where some of that authorization is happening, and whether it's determining whether a person has been authenticated or not, whether they have the right credentials. But that's part of Behemoth's installation and Behemoth's coding as opposed to what we're looking at here. I spend my first couple of days in an application, the first limited amount of time in mapping out all of these different endpoints. I've had applications that have hundreds, if not thousands of endpoints, and I've had applications that have like 20. It just really depends on the use case and what it is that the developers intend. So I think we step into actual mapping here next, right? Yep. And there is a little bit of an art and voodoo to this, but it's not. It's really not that complex. If we look at any typical application,
I think we have to go back a slide. Sorry, I think it skipped forward a slide. There we go. Yeah.
Oh, it did. Okay. Yep. That's my bad. Yeah. So we're creating a map. And these are all just examples of how you actually pull some of this out. It says Node.js index.js. That may or may not be. It might be app.js because you can start from anywhere. Django and Rails is pretty well defined. Any of those web frameworks are very specific about where they start, so it's a lot easier to jump into it. Java and .NET. It depends on the framework. Like Java Spring, there's usually there's a controller folder that you're looking for, .NET a controller as well. But those endpoints typically have these three qualities that we've called out here. There's some sort of an authorization filter, as far as who can access that endpoint, some logic processing that goes on, and some sort of access to data, right? Like if we look at all applications, there's some sort of state changing or, state engine is what an application is. So it has to have data coming from somewhere. It acts on that data, it does some logic, and then it stores data out, or configuration or whatever it is, and then it responds in some manner. But that's typically what the endpoints have when we're looking at code, what those three different qualities.
Yeah. And like, if you go back to, sorry, real quick, I wanted to add a couple things here. One is there is a concept of, so I'm using the term framework, but you can think of it as like an opinionated framework would be something like Rails or Django, where it's a little bit more, and Rails is probably the most opinionated framework, or one of the most opinionated frameworks, meaning things go in a specific place. That's why you see config/routes.rb. Like things go in a specific place. They don't really change. We know what to expect because it's always going to have the same basic sort of annotations and in the same file locations. And so that's very easy to understand. It's one of the reasons that Brakeman, the free open source Rails security scanner works so well as opposed to all of the other scanners that are out there that are free, is that it's easier to follow something that is going to always do things in a certain way, right? Controllers are always going to be under the app controllers folder. The models follow the same thing, same file location. The routes are in the same place. Now, there's a separate from an opinionated framework, the idea of a sort of piece together, middleware. Like you choose your own like data store libraries. You might choose your own web server. You're going to basically, there's a lot of options that you can pick from there or take out or put in or whatever. It's not necessarily as bound to a specific flow. And so that's why we show you all these examples, because it can look very different. And that's where what you did in the previous section is going to matter here. We need to know our tech stack so we understand, like, well, how's routing done here? Where can we expect route definitions to be? And by routes, we really just mean like the HTTP path. Like there's going to be a path that, /homepage or something, right? Or /dashboard. And the application is going to receive that request. And now it needs to determine what to do with that request and where it's going to go next. And that's what we're talking about, that end-to-end flow. So first you have to define the route path and then tell it where it's going to be processed later. And that's essentially what we're talking about. So that's the two things I wanted to touch on there, Seth.
Okay, cool. So I mean, the next is just a diagram that gives our typical application flow as far as what we're looking for. A user sitting on the left, there's some sort of routing as they're trying to interact with the application. The application makes authorization decisions based on those authorization functions. And then it either allows things through or it doesn't. Some sort of processing logic stored in the database. Maybe it calls an external service, maybe it doesn't. Could do either or neither of those things, and then return some data to the user. So that's all we're looking for when we're analyzing or we're mapping out an application. So for Rails, and I'll let Ken speak to Rails a little bit more because he is more of the expert on Rails than I am, right? Just has more familiarity with it. But it is extremely opinionated. So it's pretty easy to suss out these different items, even coming into it. And this is where the Rails documentation is going to be helpful to us, right? Is looking and seeing where things are actually set up, where things are defined, what happens in each of these different sections, and then going from there, right? Making a note of it so we can come back later on to check for more vulnerabilities. But Ken, any items there?
Yeah, under that authorization section where it says before action, before filter, again, going back to what I talked about with different major and minor versions of frameworks, like that actually is specifically because it's before action in one version and it's before filter in another version. So that's why I put both in there. These are for a very opinionated framework. It's like, use these. These are going to be those are going to be the names of your authorization functions. They're going to be applied. You're going to know where to look for them. In Rails, it's actually inside of your controller file, right? So you see app where it says processing logic. This is where okay, you've meet the minimum bar for the authorization, whatever, or maybe it's just checking if you're logged in or if you have administrative rights. Okay, cool. Your thumbs up to proceed forward. And at this point, some logic's gonna, whatever information you sent to the application is going to be processed. Maybe it's going to pull from a data store. Maybe it's going to write to a data store. Maybe it's going to maybe it's going to like push an event to a webhook listener on some other app. Maybe it's going to push to a Kafka queue. We don't know yet, but it is some external other thing that it's pushing off into. But anyways, so going back to that controller though, the interesting thing you're going to find is that the authorization decorators may live inside of the controller file, like literally app/controllers/dashboard_controller.rb. And then there's like an actual authorization filter that's like maybe before action is logged inside of that file. That's one way to do it. And again, you don't have to remember all this. There's like so many of this. We have visuals everywhere in here. You don't have to remember any of what I'm saying in terms of like the specifics. You'll see this reiterated. But why it's important to call that out is sometimes it's in the route definition, which we also show. So sometimes during the actual route definition, you're going to say, hey, for this route, it's going to be, this decorator applied to that route. And so it's not even in the controller file. And again, this is why you need to know the tech stack and you need to do a little bit of homework before you start digging in on, looking for vulns or running a scanner or something.
Yep. Cool. Yep. This is okay. Rake routes. There's some hints or there's some helpers with these opinionated frameworks for determining what endpoints actually exist. Just based on, it's just a function that you can run. Rake will enumerate all the routes that exist. Do you want to show this, Ken, at this point, or you want to just?
Yeah. Well, for sure. And like, I wanted to point out here too, just that, this exists and we show another version of this, but they're usually, if it's not built into whatever tech stack you're using, usually there's a library you can install to like basically dump out a list like this. It just makes it easier when you go to copy and paste and build your checklist of like source to sync routes. That's the only reason we show this. Also, because in something like Rails, it's really, Ruby is a frustrating language for people, and it's deserving of that frustration, if you ask me. I love it, and I've also loathed it at times. And why I say all this is that in that config routes.rb, if you were to go and just look at a a routes.rb file, there's so much like meta programming and abstraction. It actually doesn't look clear cut at all, like what you see here. So being able to have some tool like this available is super useful. That's just the point that I like to, meaning, yes, if you have nothing but source code, it's fine. But like, if you can also install and run commands like this, it's great also, because it just makes it simpler. If you go to the next slide, I'll actually break all this down a little bit better. So, and do I have control, or I'm going to request remote control here.
Cool. Okay.
Cool. So the first, let's go through, I said it, I said we break this down visually. If I can get it to, there we go. So the actual path name is a reference internal inside of a Rails application. Again, this isn't so that you become a Rails application expert. This is actually just what we're going to do is show you this routing and mapping concept in multiple languages and frameworks. I'm just starting here with Rails to give you an idea of just how it looks in different frameworks. So inside of Rails, forgot_password_path is a reference you'll see throughout the application whenever someone wants to send somebody to /forgot password. So if you ever are going through an application and you see under like a postfix _path, right? Appended to something. So if you see forgot_password_path, that's a reference to this specific function. So that's basically what I've highlighted as an alias. That's all I'm trying to say. It's an alias. This is the actual HTTP verb. Now, this is super important, right? One of the vulns we'll talk about is, what am I trying to say? Method interchange. where, well, we'll get into that, but it's important to make sure that this isn't like both get and post. And we'll get into why if you're not familiar with method interchange vulnerabilities. But it's important to know the HTTP verb, right? Stateful or dangerous, as it's according to RFC standard, dangerous verbs you should not be doing like CRUD operations on a get, right? It should be like put, post, patch, delete. So that's important to list out. And then here's the path, the actual like path name, the HTTP path rather. You see the formats because you can send .json, .xml. I think there's maybe another dot extension you can send, and it just cleans it up for that format. So the framework will automatically allow you to, give back like a JSON content or an XML content type. And then this actually is a reference to where in the source code that this path is going to get routed to. So this tells you that it's into the password underscore resets underscore controller.rb. So it'll always be postfixed with underscore controller.rb. And then inside that file, there would be a method called forgot password. It'll be defined as forgot password. And this is where the actual logic processing occurs. So that's how in Rails that looks. Is there anything to add before I move on, Seth?
The only thing I was going to say is that most of the other utilities that'll dump this have the same sort of information. So you'll start to recognize kind of these formats and how things are put together and how they're referenced from the code, right? It's fairly straightforward is really what it boils down to. And then if you don't have rake routes, then you have to look at config routes.rb, right? That's what you were saying before. And
which that resources users do block there is not super, that's not super bad, but this can get like really down like several levels and it just becomes hard to read, honestly.
Yeah, because I don't think it shows it here, but even sessions, right? Let's see. Yeah, because like resources sessions, you see how it had all the different endpoints that were listed out from rake routes, but they're in the routes RB file. It's just that single one. So if you're not familiar, again, framework documentation is your friend. We already know that this application we're looking at is Rails. We should know where to go for questions like this. Hey, what does resources do? I mean, you can always ask Google, but then you're going to end up on Stack Overflow, and I don't take any credit for the kind of code that comes out of it. Ken and GitHub might, but I don't, right? So,
Copilot jokes abound.
Yes, they do.
Yeah, no, and actually to Seth's point, that line 15 where it says resources sessions, like if you're not familiar with the nuances of the framework and you haven't looked up literally just documentation on routing, it may not be clear that immediately creates 7 separate routes to so meaning like you don't see it here. All you see is resources sessions, but now inside the sessions controller, there will be assumed that there are methods defined for 7 specific, I don't remember all the names, but it's like update, destroy, create, index. I'm sure I'm forgetting a few more. Obviously I'm forgetting a few more. But those 7 routes are automatically, there's a route set up for it. So even if you haven't defined the method, the application thinks that, you can do like send a request to /sessions/index, and there should be or however the format's going to look. Maybe it's just a get request to /index, that there will be a method to actually like respond to that and then render some HTML. So anyways, these are just nuances of one framework. That's all.
Yep.
Now the weirdness. Again, this is to show you examples of why these frameworks can be frustratingly annoying and why you have to do some homework and read the documentation. So can anybody on this call tell me what inside of Rails and specific to the routing aspect of Rails, what do put, patch, delete, and post HTTP verb types all have in common? And I'll like, they modify data. That's one example. So it's not modified data. I guess Well, they all should be used to modify data. That's correct in that, you should be using those to do like CRUD operations. But the weird thing about it is that let me, if I can hit this. It's like weird for some reason. I'm having some latency. That's great. Sorry. They're all post requests. So this is something that, again, throws people off if they're not familiar with the framework and didn't do any like reading about how it routes. So in Rails, all 4 of those HTTP requests are post requests. So literally, if you were to proxy them with burp or zap or something like that, you would see that they're always a HTTP post request. But the one thing that delineates what type internally to Rails, so instead of sending like a put or patch or delete, like in the actual, header to define that, they put in a parameter in the body of the request called _method. And then that has a value of either put, patch, delete, whatever. And so that's how the Rails internal routing determines if it's like what type of request it is, which is super weird to me. I mean, that's a strange thing. I don't think most people would expect that every one of these is actually a post request and it relies on a HTTP parameter to make that decision. But yeah, that's a nuance that we like to point out because, there's lots of weird nuances. And here's what it looks like in practical terms. So if you look at that highlighted bit there, look at the top left, very top, you see post /join. But this is actually a patch request. So this actual request will go to whoever route definition for patch was made inside the routes file. So this is important to know.
Yep.
Sorry. All right. You want to talk to this one, Seth?
Yep, sure. So that brings us to Node. So that was Rails, Ruby. If you get into it, great. If not, great. Right? It depends on what code base you're looking at. Routing in Node.js Express it's a lot more freeform because you can just choose what you want to do as a developer. There's not as much prescriptive overhead that you have to deal with as with Rails. And then we'll look at Django in a minute as well. But in this case, index.js, the routing could be anywhere from a subset of the file that's called initially to start up Node, right? Whether that's app.js, index.js. Authorization happens somewhere, usually in a post or a get or a patch or whatever else, right? And the processing logic is sent on to another file or another function that's been imported. So the example here, app.post / goes to index. Index is going to be defined as a function somewhere else in this file. But what we'll notice there is there's not necessarily an authorization that goes into it. It may or may not be defined here within that. And so we've got to do a little bit of research into what the authorization logic and authorization functions look like. But let's see, our formula on Node is super basic, right? And I know Ken does the same thing. Like I do a bunch of searches for either app.get or route.get, depending on what they define in that initial call. It's going to depend on what the name of the application is. Yeah, let me see if there's something else there. But realistically, I'm just looking through the code base for that sort of I'm doing a simple code search to pull out all of the different endpoints. And then once I get an idea of how the developer has implemented it, I may go through different controller files or different JS files that have those all defined to make sure I'm not missing anything. And maybe even in doing a search for .get or .post instead of app, because it may be called different things for different portions depending on the developers that have called it out. Any other hints there, Ken, that you've got for Node?
Yes, I'm actually pulling up something real quick to give kind of just a better, or not a better, just sort of like a visual for what you were talking about. So let me share real quick this. Continue. I know we keep bouncing between the two. All right. So going back to it, what Seth was saying there is that in this case, we've got like this is a route. This is for Behemoth. This is the routes file. And here you can see that we've got this app object that's going to be passed into, the configure. And then you see app.get. If this was what he was saying was this could be, or this, well, there you go. That was one way to do it, Ken. All right. So he could have done something like anything really. You just be it like route or rowdy, make route. It doesn't really matter, right? Like, and then here it would be that same thing, right? Rowdy, make route. Very professional name I chose. But anyways, that's what he's saying when it could be app.get or route.get or whatever. So let me give it back over to you, Seth. And there is another thing I wanted to touch upon. Let me stop sharing here. If I could figure it out where the controls are at. Actually,
I'm having a hard.
Yeah, thanks.
I just took it back over. There you go.
And I'll show it, by the way, Seth, in a slide or two, the semgrep.
Yep, that's great. Yeah, so in this case, right, we're looking at node goat, whatever, right? It's just a different node application. Searching for app.get, 17 results. Looks like most of those are in index.js, but you'll notice there's a couple different other files that we have to be aware of. And especially when there's admin functionality or other things, right? We should know that it exists, but those could be defined in other places. Okay, and then and then we're on to semgrep. So this is where Ken's going to show actually using semgrep to identify those endpoints instead of just the IDE itself.
Yeah, so here, semgrep. Let me first say, semgrep it's its own thing, and we don't have in 2 days time to go super in depth into all of semgrep. I want to show you some just basic usage here for this purpose, and then really at that point, if you want to get deeper into it, use it in your workflow. I highly recommend it. Again, it is free for the community use. And, but yeah, we're not going to spend the entire time, but what you see on semgrep, but what you see on the left is a rule. So it's app dot, and I have this placeholder, which is $method and then ellipses. And that's great because it's like, a simple search for, it's the same as searching for app dot whatever, app dot get, app dot post, whatever. And that's great. It'll help us easily find all of the locations where this stuff's defined. And I'll show that in a second in actually running it. However, one thing is we talked about maybe there are authorization decorators that need to be applied that aren't. So, and we're getting a little bit, because that's the next section is talking about authorization functions. But in this case, like if you look below the highlighted on the right, if you look below the highlighted pink box there, you see app.get dashboard, and you see is logged in, and you see session handler.display welcome page. So there are 3 specific things passed into app.get on line 42 there. There's a HTTP path. There's presumably that could be anything that's just middleware. So that could be middleware that does something nothing to do with security, but right there we do see is logged in, kind of does seem like a security function. And then there's a third thing, which is like the logic processing session handler.display welcome page. Right now, the reason you see that rule where it says and is not, and I put in 3 just arbitrary X, Y, Z were just made up. They're just arbitrary values. So is method. All that stuff's just arbitrary. It just means, so it's just a placeholder for variable data. What I'm trying to do there is find out when I don't see 3 specific arguments passed into app.whatever, then there may be a situation where it's being sent, like the request is being sent right off to the logic processing unit without any middleware, without any authorization whatsoever in place. And now I can build a negative, essentially a list of things where maybe an authorization decorator is not applied. So just to recap and just condense all those words I just said, if 2 things are passed into app.whatever, it means there may not be an authorization function in use. And if there's 3 things, which seems to be the pattern in this, this is node goat, by the way, that's what you're looking at, that code. It's node goat, an OWASP project. If there's 3 things passed in, probably fine. If there's two things passed in, probably not fine. That's what I'm trying to say. And that's what semgrep is allowing me to do. Now, semgrep gets a lot more in depth than this. This is just a very, very, very basic usage. And now I'm going to share my screen again and put poor Seth through the ringer on managing screen sharing. But yeah, I'm going to just kind of walk through that real quick. So
yeah, and the one thing I wanted to say, the reason that we bring up semgrep is that a lot of the code review that we do is looking for I want to say false positives, but that's not it. So we're looking for specific patterns or lack of patterns. And it's hard to do a search through an IDE looking for code that doesn't exist, right? You can't, it's hard to do that, to write that sort of a regular expression. Whereas, so if I was looking for this in the IDE like Ken is, I'd be looking for app.get and then going through each of the items and looking for ones where is logged in doesn't exist. But we're speeding up that process. We're using semgrep to just give us a list off the top of our, at the beginning of all these items that are accessible without having those three different calls or those three different parameters in it. So
yeah, so like right here with the playground bit, this is where you can actually mess around and you can actually add things, and meaning like you can add rules. They have specific examples. You can try looking for certain things. We actually show one of those with doing something similar like this for Flask, using an example they show. And yeah, you can basically just like create all your, in whatever language you want, you create your rules. And then when you're ready to actually export them and use them, so here's where I build them and I test them out and I can run them and I can see if they're actually working. And it does look like, it's finding the things where there's only 2 arguments passed in, or not 3 arguments passed in. There could be 4 passed in. It's going to find whatever is not matching 3 arguments passed in. So cool, we're good. It's doing what it's supposed to do. I want to take this and actually run this now, right? So I'm going to go over to the advanced tab here, which is the actual rule. This is everything we just did, but in a rule form. I'll go ahead and create this my rule file, and I'm going to open it up with Adam. Or at least I think I will. Oh, it's in a different window. My bad. All right. So, sorry, I'm dragging this down. So now you should see like an empty my rule file. So I'm going to go ahead and paste that in. And paste that regex in that I built. And then I'm just going to run it. So to run it, I'm going to run semgrep, and I'm going to give it a config file. Wow, there's a lot of stuff. There we go. I'm going to give it a blow this up real quick. There we go. I'm going to give it that my rule file, and then I'm just going to the dot annotation is just to say like run it in this directory where all the source code's at. So I'll run that rule, and it'll if it works, it's going to give me a list of everywhere where only 2 of the 2 arguments are passed into that app dot whatever. Yeah, so we've got more than just our original results where it was app get post app. There's also, and we talk about what app.use is and some edge cases around that. But yeah, there's like a whole list of various areas where it gives you the file name, and it tells you what line number, and it just gives you all those results. So it's really, really handy. And honestly, this is really handy in a CI/CD. So somebody had mentioned in the very beginning when we did introductions that they're kind of trying to run pretty fast with in terms of automation, and this would help you, I think, is determining, once you understand the application's makeups that you're looking at, once you understand what to look for and what rules you want to write, I think it's a good thing to export this and create a CI/CD pipeline where you automatically flag on, any high risk findings that or any of the results that pop up. So that's semgrep in a nutshell. Oh my goodness, Already 3 almost.
Yeah, it's almost lunchtime, but let's see if we can get through mapping. Right. Okay, so that was demo time. We've already kind of looked at these, so we're going to skip along here because we've talked about the close look. Django application flow. Like there's a urls.py file that defines where everything comes from, and this one in this case sucks in something else, and there is like details. I'm trying to decide how important all this is, but realistically it's just the path again, and then the views, where it's actually calling to after the fact. The decorators themselves, or the authorization functions for Django, actually end up being either in the code base itself or as decorators in the views.py file. They're not in the actual route definition. There is a Django extension that'll do a similar thing to what Ken was looking at previously, or with Rails, in this case, show URLs. So manage.py, if you've dealt with Django before, actually, is the Django manager for the application itself. And you'll see, there's a whole bunch of stuff, even like definitions of the rights that are required to actually get to that. Like that first one, login required, that's the decorator that's being called to access the index page. Whereas the admin page, it looks like there is an admin index role that you have to have, or permission that you have to access that page, and so on. So it's fairly easy from there. It's a little harder to see from the urls.py perspective, but it's all accessible. If you've looked at the documentation, it comes out fairly quickly, and you're able to identify it. Now, what we don't have here is a get, post, patch, right? How that's actually handled. So it's something else that we may need to dig into further.
Yeah, and so this is what I was talking about in terms of basically an example that they show on SemGrep's website when I was talking about like example rule sets. This one is actually for missing decorator annotations. So you see on the lines 4 through 7. So look down below under test code. If you look at lines 4 through 7, on line 5, there's a @login required decorator. And in a moment, I'll go back a few slides and look at the actual like processing flow just real quick, because I do want to touch on a couple things there. But to Seth's point, first of all, if you look on line 4, you see methods equals post. Now that could be multiple methods, and this is where we get into method interchange issues, and we'll talk about that and why that vulnerability exists and why it's a vulnerability and all that fun stuff. But anyways, the point is that lines 9 through 11, no @login required. Lines 4 through 7, login required. So this semgrep rule at the top, where it says semgrep rule, and it shows like here's the code looks like this and is not this, right? It doesn't have the login required, then highlight it, because it means there's a missing decorator that's super important for authorization. Flag it, raise it, let's list it, and then let's go take a look at it later. Not now, because that's going down the rabbit hole. But for now, just list it out. Now, I'm going to skip back, or if you could go back a few slides to the actual flow there. You keep going. There we go. All right. So like Seth briefly touched upon it, but views.py, this is the weirdest thing. Django is technically like an MVC, but it's not an MVC. So it's like this weird thing, again, when you talk about framework weirdness and understanding the framework that you're looking at. Like I would think, coming from every other framework, that views.py would be like maybe some HTML kind of like templating stuff that gets compiled and rendered as like some HTML page. It's not. Views.py is actually like, it should be like controllers.py, because that's where all the processing logic actually occurs, but it's views. I think it's called the MVT, like a models view template language, but it follows an MVC like flow, even though it's special. In the data store, models.py, all that stuff's pretty normal. But back to the authorization, the one other thing I wanted to mention is that the @login, actually two other things. @login required is just one example of a decorator that's built into Django. So if you go to and I don't know if we want to do this now, Seth, but if you were to look at the Django documentation and look at its decorators, you would need to find out, is @login required a custom defined decorator that somebody wrote that built this application, or is it something that just comes default with the application? And so when you dig in and you actually look at like, oh, this is part of, this Django auth contrib library, you're like, okay, wait a second, where am I calling in Django contrib auth? What files are calling that in? Like what other decorators am I using here? What other decorators does this documentation provide us? This is where we start to begin to really look at documentation on any framework or web server that we're going to assess. So, and then if you go back to the slide, Seth, just like you'll see that in the next two slides, that's where we see like, oh yeah, sure enough, there's Django contrib import admin there on line 4. And to Seth's point, we're including other URLs. So even though urls.py is where it starts because Django is opinionated, and to some degree anyways, and it starts with all your routes being defined in urls.py, you can include other URL routing files like this, which is the task manager _ URL file. And then there's additional routes defined in there that you need to go look at. So those are just the things I wanted to cover real quick about framework nuances with Django.
Yep. Yeah, and I don't know, Django, any of these languages and any of the frameworks that we look at, you're going to run into these kind of nuances, and you're going to hear us say framework nuances. I'd say it should be a drinking game, but then none of us would get anything out of this course if we did that, because there is so much. I mean, that's why we build applications in the different frameworks, is because of the nuances and what we can do with each of them, but we got to get to know that very quickly. So, I mean, you saw me Google login required, go to the Django documentation. I probably want to make sure that I'm on the right version as it is, but even then, it's very descriptive as far as what's going on with Django and where that actually exists. So that was semgrep notation. Yeah, let's get through mapping. Do we want to try to do the exercise before we break for lunch? Ken, is that what you want to do, or how do you want to handle it? Okay.
Yeah, I think we should do the exercise, come back, do like an overview of the post mortem on that, and then yeah, probably just lunchtime at that point.
Okay, so that sounds great. From a routing perspective, .NET. So this is really .NET Core. Again, .NET and Java, there's so many different frameworks. It's really going to depend on the code base that you're looking at. I usually see controllers. I usually see models. Sometimes there's routes, definitions, but but it's usually all within the controller. And then there's interceptors or filters that can be applied before, and then the authorization decorators. So there's a lot to consider. If we're looking at this sample code here, so for mini blog, you'll see this authorize header that comes in from, I think it's the ASP.NET Core authorization. So it's built into ASP.NET Core, and you can use it if you are using the right authentication mechanisms within ASP.NET. But again, it's going to depend. I hate to say that it depends, but with all code, it depends, right? Like you guys have already jumped on that. Yeah, authorization and then authorize. That's where it's coming in. But again, I'd be Googling this if I'd never looked at .NET Core before. Here's another example. They always allow, I love the allow anonymous, because that allows us to search quickly for anything that's accessible that maybe doesn't have authentication on it. Yeah, that's always a good place to start, but at least we know that exists for both of those login routes. Looks like one is an asynchronous login, requires an anti-forgery token. The other one doesn't. Whether or not that's a security issue, we don't know at this point, but we can note both of those routes before we move on. Oh, wait, one's get, one's post. That's why.
Yeah, and then going back to that, with the one being post, note that third thing that's passed in there. That's a validate anti-forgery token. It seems important. This is something I'd be like, okay, That sounds important. That sounds like it's CSRF protection related. I'm going to go Google it and I'm going to figure out how that works. And I'm going to figure out if there's any like weird things that I need to know about. Like if you do this or that, like it won't maybe be actually implemented. I've seen weird things like that. But anyways, either way, you know that if you see an HTTP post and put and patch and whatever, validate anti-forgery tokens should be there. So your job should be to use something like SemGrep to look up when that's not there.
Yep.
But again, at this stage, we're learning. We're not finding bugs.
Yep. So at this stage, we're noting, okay, there's a login, but we're also these authorization decorators. As we're going through each of the endpoints, we're going to note, okay, there's an allow anonymous, there's a validate anti-forgery token, there's an authorize decorator. Those are all authorization functions we're going to be concerned about when we get to the authorization checklist. Java Spring specifically is similar, although they do have like the Spring filters that will handle some of the authentication and authorization, but it usually has decorators or usually involves decorators to get to that point. And yeah, I mean, controller.java, so some like home controller.java or dashboard controller.java, we'll typically see something along those lines. Most Java developers follow some sort of preset framework or preset definitions in that, but it doesn't mean that they all do. Okay, so this brings us to Rufus. We're going to do information gathering. We're going to start, we're going to do Skia node. So you're going to create a new example template for Skia node, figure out what it's for, right? Why the application exists, do the tech stack, the info gathering step, business purpose, small risk assessment, and then you're going to map out the routes of Skia node. And then once you get through with that, you're going to map routes for Behemoth. We've already given you some indications on what that's going to look like. You don't need to use SemGrep in this case. Let's just use the IDE, do the searches like we talked about with app.get, app.post, figure out where they exist, look at index.js. But let's start first of all with Skia node. We want you to exercise those muscles, get used to the idea of doing tech stack, biz purpose, and risk assessment on each of these applications. You're going to do this multiple times. So do that first, map out the routes. Skia node's pretty simple. And then let's move on to Behemoth. So what do you say we do 15 minutes on this, then we'll talk, and then we'll break for lunch after that?
Yeah, that sounds great. Just to reiterate, you mentioned it, Seth, but I want to drive this point home. Follow along with all of this, please, because this is this drilling. That's really what we're doing. We're drilling. We're building it into your experience and into your memory. And all of these are going to build on one another. So there's a reason we're having you drill. It's important, rather than just being like, hey, we're going to talk for 8 hours and then like maybe we'll do some hands-on stuff. There's a reason. So please follow along. Thank you.
Okay. Cool. All right. So jump into it. We're available if you have questions, but copy example template and go for it, right?
So do you want to actually just do like 30 after? So it'd be given 20 minutes to do this?
Yeah, sure. That's fine. I mean, I think everybody's in kind of different time zones, so it's fine. And then we'll break after that. So yeah, we'll do 30 after and then talk. Okay.
Thank you. So I was typing an answer, and but I just figured I'd call this out. Um, in the cases where I don't have a README, I would check out. So this doesn't have a README. It's a very simple app. And in those cases, and even if I do have a README, I like to look at the actual like package files, and they vary. In Node, package.json is, where all your libraries are going to be listed, and this helps you get a understanding of the tech stack, right? Because you'll see libraries, like opening this one up. You'll see Helmet, you'll see Express, the versions, you'll see C surf, literally C and then the word surf all combined. That's the C surf library. And in, say, Rails, it would be like a gem file. In uh, like a Java, it might be like a POM XML. It just varies between different types of applications what the library listing is going to be, and that helps you determine sort of like some of the. And we walk through more of this later, but just because it had been asked about the README, there is no README, but there are other ways to determine the tech stack. So I hope that helps. Cool.
All right. It's time.
I was listening to some music while we waited, and you surprised me when you hopped on.
Oh, good. Good. Okay, so Skia node. Who wants to jump in there? Ilya, I think or Chris, I think you're right. I don't think there's a README in there. I think there's just code in this one. Some of the example ones we weren't super disciplined about, right? I'm going to blame Ken. He's the node developer on this. So that's how this goes. Throw everybody under the bus.
It's actually something I talked about when we cut out for break. A few minutes went by, and I explained that, essentially, and we end up showing this later in the course. Just basically, like, you can look at in this case, a package.json, but any dependency file that you look at will give you a pretty good idea of the libraries that make up an application's tech stack. And in the case there is no README, there are other places to look, such as that specifically. So in this one, you immediately get some pretty good info about looks a little different. Can you go to package? Can you go back?
Yep.
You go to package lock.json. That's probably a little bit more comprehensive version of all the different things that end up making up the application. So there's a lot in there, but I had mentioned like C surf should be in there and stuff like that. So yeah.
C surf, maybe nope. All right. So so it's obviously Node, right? Mike says there's a README under the source map folder. And that could be the case. Like if we look under source map, because source map is a dependency, right?
Those are just the libraries that it includes that have been vendored. We call it vendoring in. They've just been included in the source code. So when that package, when the libraries were imported based off that package.json, they were all placed under this location. So there may be a README, but it's specific to just one of the libraries, which in this case is source map, that comprises the greater Skia node application. So just to summarize that, the Skia node app is comprised of many different libraries, like most web frameworks, and they're all contained under the node modules folder. So there might be READMEs just because, those repos were essentially downloaded into that folder, but they're not the README for this application.
Yep. Yeah, so there's no README to go from. So, where it's Node, I'm going to start at app.js, but anybody else have indicators there, right? Like as to what it is before we jump into it. What does the application do? What does the purpose behind it seem to be? Outside of being a simple Node app, right? That's all we got here. It's the about. Anyone? List users. Okay. Where'd you get that from, Mike? Yeah. It seems to me, the routes. Okay, so if you looked at the routes, that's what. Yeah, there's definitely reusers. Dude, it looks very simple, right? Like there's not a lot there in that routes. Express, right? Yeah, there's really nothing much there.
Yeah, someone wrote it seems like it's a lot of template boilerplate. It's a very small app for a very specific reason.
Mm-hmm. Good. Okay, so what were the routes that everybody identified? And these get to be kind of interesting. I know that, Mike, you already talked about the users routes, list users out. And this has specific reason, right? Yeah. Yep.
Yeah. In fact, if you allow me to share my screen, I want to cover that while we're we're at that point where I kind of wanted to give everybody a little, we throw in a little bit of stuff to kind of, I mean, I don't want to say mess with you, but it is to like create realistic scenarios of like when
What
you
the
don't
guts is
have
going on.
when you don't have a lot to go on. The whole idea here is that you are going to have this happen. And in these cases, it's going back to our methodology. So in this case, somebody mentioned the WTF, and that is a very specific reason that I threw that in. So I wanted to share a story real quick about, sorry, I'm pulling up also some routing documentation here. So just real quick, sharing my screen. Okay. All right. So we had an issue where I had mentioned I was going to touch upon the use function. So the use function can be used to be applied to multiple routes. So to explain that, if I could use in this case, router.use or app.use or whatever, and I can apply some logic, and this would be my function that does something. In this case, it's just logging. But if I wanted to have a function that actually did something that was like authorization centric, I would actually put all that authorization stuff in here. And then I could actually apply, I can apply it to any route that matches a specific set of regex. And that's why I brought this up. There was a flaw not caught because there wasn't a lot of homework done on the routing nuances inside of Node. And inside of Node, there's actually this ability to do regex. And so you see regex here, you see regex here. And that is, just to recap, it can get dicey, right? We've all dealt with regular expression. We've all dealt with, making or having flaws around, essentially regex. And Node allows you to create route author or apply route authorization based off of regex. So in our case, the flaw manifested because there was a function that was created to do some authorization logic. In this case, it was an administrative check to make sure you're an admin. It was applied to any route that matched the regex, and the regex was flawed. So literally every administrative endpoint had no authorization applied to it whatsoever. And I think I like to highlight this because it goes to show, if you don't look at the documentation and you don't look at the routing documentation for something like, say, in this case, Express, Node Express, or it could be anything. It could be some Scala app that you're looking at, some Play Framework app. It could be, I don't know, just anything, right? If you don't look up and understand this type of information, then you might actually miss that there's like multiple ways to define a route, how the weird ways that you can define routes are set up. And so in our slides, we show you that effectively, and in that source code, anything that goes to W anything F is going to go to the same place always. So again, this is just to highlight, like, the Skia Node is a very small app, and it's got a very specific purpose. And that purpose is to show you where these nuances lie. So let me stop sharing and go back to you, Seth, and give it over to you.
Got it. Okay.
Cool.
All right. So that takes us through the postmortem of.
There's a couple more things I was curious about if anybody caught the fact about, like, if those two little things right there, the auth function that doesn't do anything. And or the fact that the debug statement prints environment variables. I don't know if anybody caught that. Why that's funny is this actually is another, again, going back to a story that happened. This has very much happened where there was a route that was used for like debugging and testing, and it printed out environment variables. And what do we put in environment variables most often, Seth?
Session secrets.
Secrets, keys, remote DB connections, whatever it might be, right? That's sensitive. So yeah, And then you said process.env, which is basically all of the environment variables for that on line 29. Yeah, so I was just curious if anyone actually caught that, because that's put in a couple things there to see if anybody would catch the auth function doesn't literally do anything, like is authenticated. Next. Like, and this is another time I want to I guess stamp on, I can't really do it because we're not in the classroom. I can't like stamp my foot or pound on something. But when you go through, we go into more and more of these exercises where we start to look for vulns, and just in your regular day-to-day life, I put inside that, or day-to-day work, I put inside that, this code right here, a few things: hack, fix me, to do, a few different like debug in the comments. And again, going back to like either you're doing like a regex search or using something like semgrep, whatever the case may be, trying to apply stay on task. So noted it, but didn't pursue for exactly. First of all, 2 thumbs up for you, Nathaniel. That's exactly what you're supposed to do. Annotate it, don't pursue it. But yeah, so when you look at when you go through an application, this is one of these cheats that like we'll throw in there occasionally to speed things up for you. So you may get to a point where you're like, hey, I'm kind of slowing down. Always search for to do, hack, fix me. Search for it because it's an incredibly valuable tool. You'll find like all kinds of, I found so, Seth, how many wonky things have you found just by searching for that? Where you're like, oh, you've even called out that this doesn't do anything that it's supposed to do. And like, it needs to be fixed. And like, yeah, that's a vuln.
Yeah. Yep. Oh, I mean, it happens at least every couple of assessments, right? That there is a portion that they've, they've ignored, or they know there's an issue. Yeah, it's very common, and sometimes you don't see it in comments. You might find it in like the Git log as well, right? But it's it happens. Yeah, and you should be aware of it. So to do eventually, exactly, Mike. That's what happens. So cool. Okay. So all right, authorization functions. I think we're gonna finish up Rufus. As far as Behemoth goes, did anybody find interesting routes? Were you able to enumerate routes, or did we even get to that? Go ahead and comment in chat if you did. Yeah, just focused on Skia. That's fine. Believe there's a routes file, right? Yep. Yeah, so Behemoth is more example of what you're going to run into in a normal assessment, as far as being a consultant, like having 1,000 different routes that you look at. Yeah, so if you look, there's under the config routes, right, is where I want to go, and that's where everything's actually defined. And what do you notice here? All the routes go to other places. So it's not only that there's routes defined within config routes, but they're calling out all these different files. They don't necessarily have the authentication or authorization built into the get or post definitions. ID parameters are all over the place: get, post, delete. I would start by dumping this all directly into a markdown file and starting to get my hands around it, right? To know what's important and what's not, because there's a lot of indicators in here of risky data, risky functions, things that I'm probably going to want to look at some point. And I'm either going to just note this file, or I'm going to copy it in directly so that I've got it in my notes, so that I can start to annotate what's interesting to me and calling out those interesting points. If there's 1,000 of them, maybe I just refer back to this as I'm going through and building my checklist and pulling out the interesting ones that I want to research. Yeah, so Mike, over 300 just .gets. That, for a couple of day effort, that sounds pretty extreme. For a couple week effort, that's probably pretty normal. But
And
Yeah,
we
so
do go
there's a
through
lot there.
prioritizing these, by the way,
Yeah.
in future exercises.
Yeah.
And also, one thing I want to call out here is that we are going to do a few more exercises where you bounce around different code bases, but we will eventually land once we've put you through the ringer on. And sorry, but that's part of the course. It's going to push you outside your comfort zone. We're going to go through a different technology stacks for a reason. We're going to go through different applications, but then we'll as we start to get more towards like we don't need to like redo the same thing over and over again, here in a few exercises we'll be sticking with one tech stack at that point, but not now.
Yep. Not now. We're going to do another one here for authorization functions after we get back from lunch. So let's go ahead and break. I know we've been going for a while. Everybody go get some food, get some caffeine, and yeah, we'll deal with it from there. Okay. What time do you want to start back up? Do you think? What? So it'd be, dang, that'd be 2 o'clock. Is that right? Yeah, 2 o'clock Pacific.
Wait. So it's current. I'm doing math. So now it's currently 12:46. So that'd be an
hour and 15.
Were we told that we need to give people an hour and 15? I don't know if we want to go the full, because that just because for the time constraints.
Yeah. Either way.
Yeah. I mean, was it an hour? I think it was an hour lunch though, right? We were asked to give. Yeah.
Yep.
I would
yep.
just do an hour because honestly, we just have, how it goes. We always have a lot of content to get through. So.
Okay. Yep. So we'll circle back at 1:30 or 1:45. Sorry, let's do 1:45. So let's let everybody break. We'll start back up at 1:45 Pacific, and jump straight back into authorization functions, wrap that up, and finally get into authorization controllers.
Apologies, Diane. We need the full 8 hours for this course. Stop by 6 p.m. Do you mean?
Are you saying 6 p.m. Pacific, Diane? Yeah.
Oh,
yeah, we'll be done
fine.
by then. Yep. For today, we'll be done by then, if not a little bit before. So.
Sorry, I thought you meant East Coast time. I was like, well, we do need the full at least 8 hours. I mean, yeah, yeah, for sure. So.
Okay.
Cool.
All right, everybody, go grab lunch, and we will talk to you in an hour.
Awesome.
All right. Thanks.